Alrighty, hi everyone. I'm going to be continuing the CS50 course overview by talking about week 1. So let's go ahead and get right into it. So right here we have the CS50 week 1 overview. So we see that there's the video for week 1, which is awesome. And then we also have the outline of what's happening for the assignments. So we're going to go ahead and start with lab 1. So lab 1 is called population growth, and here are the requirements for lab 1. So basically the end goal of the program is to create an algorithm that allows us to input a starting population size and output the number of years it will require to get to the end population size. So we have this example here where the start size is 100 and then the end size is 200, and then it'll output the number of years required to get that value. So for some background, it's talking a little bit about a llama case where we start with a certain number of llamas. We're trying to figure out how many years it'll take to get the end number of llamas. And every year, and this is crucial, n divided by 3 new llamas are born, and n divided by 4 llamas pass away. So we need to figure out a way to, in our algorithm, input that every year the population should update based on this specification. So right here, it's walking us through how to go ahead and get started setting up in VS Code. And what's awesome about CS50 is that Professor Malin walks everyone through how to get that going pretty well. And there's a lot of other helpful videos within this CS50 website. So feel free to check those out. Basically, I'm just going to assume that we're all set up, we're ready to go, so we can dive into the problem. But yeah, basically just if you aren't sure what to do, follow these 4 steps and go from there. So let's go ahead and get into it. And then for a few more details about the implementation, basically the program should start by prompting the user for a starting population size, and crucially it should reject any value that is a non-number or less than 9. So that's pretty important. Another part of the specification is that the end population it must be at least equal to the starting population size. Really, to get something interesting, it should be more than that, but the program should be able to correctly handle if the end population is the same as the starting population. And then finally, the program should calculate the number of years required for the population to reach at least the size of the end value. Excellent. Okay. And it should output that answer as years n, where n is the number of years required to get to that value. Okay, so let's go ahead and get going. And here's some hints if you want to look at that. Okay, so here's the code that I ended up using to solve this problem. And what I mentioned in these other videos I've done on CS50 is definitely feel free to use this as a guide for how to start solving your problem, but don't copy and paste it because that's actually against the terms of CS50. Even if you aren't taking it for credit, it's still in your best interest to have the integrity to work on the problems by oneself and create your own solutions. But I think these videos can help people get a sense of one way to go about solving these problems. So yeah, with that in mind, let's go ahead and keep going. So yeah, this is the C language, as we know. So some things to start off with. The base code when you input the base code when you unzip the population folder has these includes. So it includes the CS50 header and the standard IO header. And then it'll prompt. And then it'll also have a few to-dos, and those are for us to figure out. So like prompt for start size, prompt for end size, etc. So let's go ahead and look at this right here. So I went ahead and used the getInt function, which is part of the CS50H header file. So I ended up declaring an int called start population, start_population. So that's basically going to be the integer that the user inputs as the starting population. And what's cool about the getInt function is that you can actually have the terminal output text, and then it retrieves an integer from the user. So I said, please input a population start size greater than or equal to 9. And this is in a do while loop. So the do while means, it's, as we know, it's going to execute this once, and then it's going to continue executing while the start population is less than 9. So if it's the case that the user inputs like a negative number or anywhere from 0 to 8, or a non-integer like potato, then it's going to continue running the while loop until it gets a starting population that is not less than 9. Next we have prompt for n size. So here what's happening is just like I did before where I declared an integer for the start population, here I declared an integer for the ending population. And if you notice, I could give these shorter names, like I could say int n or int m, but for me I wanted to give them descriptive names. That way I know exactly what's going on. So end population, really hard to mistake what that means. And just like before, I use the getInt function to have the user input a population n size, and I prompt the user with the information that it should be greater than or equal to the population start size. And this is going to run while the end population is less than start population. So if the user inputs something way less, or even a little bit close to being equal to but still less, or a non-integer, then it's going to continue running and have the user continue to be prompted until they give a valid end population. Okay, next we have calculate the number of years until we reach the threshold. So yeah, that's basically what's happening all through, right here. Let me redo that. Yeah, basically that's what's happening all through right here. So first I declared an integer called year and set it to 0. And the reason for this is basically 0 is always a really good way to start an integer if you need to have an int, but you just need to have a default value to start off. But it also serves another function, which we see later. Basically, if there's no difference between the starting value and the end value, then it should return 0 as the number of years to get to that ending value for the population. Okay, next I declared another integer called new pop per year. So this basically tracks the new population after a given year. And I initialized it to the start population. That way it would set it to be the beginning population for the very first year, or before the end of the first year. And then I declared another integer called difference, which is the end population minus start population. And the reason for this is right here. So like basically, as I wrote in the text right here, the comment, this if conditional is going to check to see if the start and end populations are equal. So if they're not equal, then it should run through the do while loop. Otherwise, print 0 years. So in other words, this is checking, hey, is this integer difference? If it's not 0, then do this. But if it is 0, meaning it's not 0, it should print years, which is equal to 0. So again, if the difference is 0, meaning the end population and the start population are the same, then it's not going to take any years for that change to happen. So it's going to print 0 years. However, if the difference is not 0, then what's going to happen is it's going to do a do while loop. So for the first iteration, it's going to set the new pop per year to new pop per year plus new pop per year divided by 3 minus new pop per year divided by 4. So this might look like a lot, but basically what's happening is it's starting off with new pop per year. New pop per year is going to be set to itself plus this and then subtracting this. So there's basically 3 different pieces happening here. So first off, whatever the new pop per year was, we want to add that to the next new population, because if we didn't have this, say we like deleted it, it would just be new pop per year divided by 3 minus new pop per year divided by 4. But the problem with that is that that's going to be really low. Like, for example, let's say new pop per year started as 1. Oh, that doesn't work. Let's say new pop per year started as 10. That would mean that, again, we're going to say we're ignoring that. So 10 divided by 3 minus 10 divided by 4, that equals roughly 3.3 minus 2.5 equals, about 0.8. But the issue with this is that, again, if we didn't have this right here and it's just canceled out, then it would set the new pop per year to 0.8. And obviously that's way less than our starting population of 10. So that's why we need to have this right here. And then it'll be 10 plus, about 0.8. So our next population is going to be around 10.8. And obviously you can't have a fraction of a llama, so it'll round down the way we're doing it, because these division operators are actually just going to cut off anything that's any decimals. It's not going to round up. And that's okay for our purposes. So that's why we have this. And then these 2 pieces come straight from the specification over. Those pieces come straight from the specification found here. So each year, n divided by 3 new llamas are born, and n divided by 4 pass away. So we add the n plus 3 because new llamas are born, and we subtract the n divided by 4 because those llamas pass away, unfortunately. But I'm sure they had a good llama life. So yeah, all that said, that's explaining that. And then now what's going to happen is we want to keep track of the number of years that are passing here. So we want to do year plus plus. You can also write this as year equals year plus 1, but I prefer the plus plus because it just looks cool and it makes sense to me. This is just iterating, so it's adding 1 per iteration. And yes, I had this here, this print function, and I commented it out, but I kept it because I used this to test if the new pop per year update was working, and it was working correctly after some tweaking. Originally, I actually didn't include that, and I was like, oh, what's wrong with my function? But I ended up figuring it out. And then this is going to repeat while new pop per year is less than n population. So originally I had this set to less than or equal to n population, but that actually didn't work because even if, like, let's say new pop per year is equal to n population, then it'll run through 1 more iteration and add a year more than it should. So it should be just, oh, I'll just delete all that. Should just be less than. So once it gets to the point when new pop per year is not less than n population, like right when it's not at that point, then it'll print the years. And then this notation, as cryptic as it looks, just makes it so that it's going to input a specific double or int in the %d, and then the variable we're using for that is year. So it'll basically print out an integer for the number of years tracked by this year plus plus in the do while function. So let's go ahead and see it in action. Oh, let me go ahead and cd into the population. Okay, cool. I'll make population. Alright, and then we want to do this to run it. So please input a population start size greater than or equal to 0. Let's mess around with it for a second, see if it'll take negative values. Okay, no, not taking -10, not taking -4, which is great, that's what we want. Now let's try doing a non-integer like potato, tomato, nope, okay. Now let's give it 9. Cool, so since 9 is equal, that works. Now we're going to input the end population. Again, we want to make sure that our equation's working okay. And yeah, so it's running all right, because every time I put something weird, it's not letting it run through. Excellent. Now let's give it a actual real number, and let's do like 19,002. So that's a lot of llamas. Now when I press enter, it's just going to return years and then colon space number of years, 95. Boom. So that's working. And then we can head back over to the specification just to make sure everything looks good. So we can do this nifty check 50 function to make sure it's actually working correctly. So we can copy that, paste it, and then we'll see if it's going to work okay based on the CS50 checker, which is really good. It'll tell you anything that's wrong, or less so, it'll tell you what's wrong, and it'll tell you what requirements your code didn't quite meet, or it'll tell you if you met all of them. So it'll give you a red sad face if it didn't it'll give you a red sad face if it didn't meet that requirement, but we got all green smiley, so we're all good. And we're pretty much ready to submit. One thing I'll do is run the style checker, because we'll be able to see like if there's any style issues we should fix. And then ours looks pretty good. I will say originally I had to change a few little style things, like for example, like let's say that these comments don't have a space right there. It'll actually flag those spaces like, hey, like you should fix that. So I'll go ahead and fix that one, boom. Good job fixing the format. Yo, instant feedback, I like it. All right, now let's go ahead and submit that. Okay. Awesome. Then that's going to go ahead and run and submit this. So this is the academic honesty checker. So keeping in mind the course's policy on academic honesty, are you sure you want to submit these files? So I'm going to say yes. I'm confident. I coded this up myself. I feel great. Perfect. Now we can see our results. That's perfect. We're going to go ahead and move on to the next piece of the week 1, which is, let me see, problem set 1. So there's a few things here in problem set 1. We have this, so the population thing was for lab 1. Now we're going to go ahead and move on to problem set 1, which has a few different subparts to it. So we have a choice between whether we want to do Mario like less or Mario more comfortable, and then we have cash credit. What I'm going to do in this video is hello, and then Mario more, and then credit. So let's go ahead and go to Mario. Oh, no, let's start with hello. So basically hello is pretty simple practice. We just want to be able to have the user input a specific thing, like a string, generally their name. That's what the specification specifically is thinking. And then output hello, that person's name. So let's go ahead and check that out. So we have hello right here. So first I'll go ahead and clear the terminal a little bit. Then we'll move into hello. All right, so very straightforward right here. So what's happening is, like before, we have the libraries right here. And then in our main function, line 7 right here is going to get a string from the user by using getString. And then it's going to prompt like, hey, like, what's your name? And then it's going to print hello, and then the %s. Like we saw earlier with %d, it's going to print a variable value. And the variable here is name. And that's from up here, string name. Cool. So let's go ahead and see it running in action. So I'll first make hello, initialize hello, and then my name is Daniel. So hello, Daniel. That worked. So let's double check if there's any other things we need to do. So we'll do check 50. And then that should tell us that things are looking good. And then generally, like I said earlier, we want to make sure we do style 50 to see if there's any style changes we need to make. But for today, for this, we're going to go ahead and assume everything looks good and then submit. So everything works great. It responds to Emma and Rodrigo. So let's go ahead and head back and submit this. Awesome. All right, so that's going to go ahead and submit after we say, yep, that's my work. Perfect. All right, now let's go ahead and head over to Mario. So this one's pretty cool. There's a few things going on here, but essentially we want to kind of emulate this pyramid structure in code by outputting specific numbers of hashes and spaces so that it can look like this cool pyramid. So for example, if the user inputs 8, then we want the pyramid to look like this, where there's a cool pyramid and the bottom row always has the number of hashes equal to the user's input, but then each row above has one less hash than that. And then there's going to be 2 spaces between each row of hashes. Let's go ahead and check out how I went ahead and implemented this. All right, so first let's go ahead and head into our directory. Mario more is this one. All right, so let's go ahead and take a quick look at what's going on here. So yeah, first we have the includes up here as we saw, and then we have these down here. So for our main function, let's go ahead and start with the initialization of the variable n. So n is going to be the integer that is generated from the user, and that's going to define what the pyramid structure is going to look like. So we're using the getInt function, and we're prompting the user, hey, type a pyramid height between 1 and 8. Inclusive, this refers to like where we say 1 to 8, we're not really meaning 2 to 7. We mean, hey, like 2 to 7 is cool, but also like you can give 1 or 8 as an input. Sometimes the 1 to 8 or similar phrases might imply that, oh, we actually don't want the min or max values, but here we do. So that's why it's 1 to 8 inclusive. And then over here, this is going to be, yes, do while. So while n is less than 1 or n is greater than 8. So basically, if n is negative infinity to 0 or n is 9 to infinity, then it's going to continue to prompt the user to input a valid integer. And this is cool because this also checks for like if they input like ramen or some other non-integer like a string or something else that's weird. So it's not gonna let them input that. Okay, so here we have a few different for loops, and these for loops are gonna set up pretty well. So it's a nested set of loops starting with this one up here. So for int I equals 0 to I is less than n, I plus plus. So Professor Malin explained this really well, but just to recap what's happening in the for loop. So for means that it's going to repeat whatever's in the brackets of the for loops so long as certain conditions are met. So it's going to start with the initialization of int I set to 0, and then for as long as I is less than n, it's going to repeat what's in the for loop. And then after each successful iteration, it's going to do I plus plus. So I is going to increase by 1. And that's true of all the other for loops here. I think the easiest way for me to explain this is going to be to run through an example. So let's go ahead and do that. So let's start with an example where n equals 2, meaning that the user has inputted 2. So let's go ahead and start with the first for loop. So int I equals 0. So I equals 0. And then I is less than 2. So it's going to go through this first nested for loop here. So for int j equals 0, so j is starting off as 0. And we're going to see if the condition is true. So 0 set is less than 2 minus I, which is 0, plus 1. Let's see if this is true. So 0 less than 2 minus 0 minus 1. So 0, the question is 0 less than 2 minus 0, which is 2, minus 1. Is 0 less than 1? Yes, it is. So since it is the case that this condition is true, then it's going to do what's in that for loop, which is print a space. Here we're going to represent the space with underscore, just because I can't physically draw a space with the pen. All right, next we're going to move on to the next iteration. So the next iteration is going to have j equal to 1, since there was a successful iteration. So we're going to test if the condition's true. So since j is 1, we're going to set j to 1. We're figuring out, okay, is 1 less than n, which is still 2, minus I, which is still 0, plus 1. So notice that this actually didn't change from last time, since I hasn't changed. But we see that if we go through this, i's 2 minus 0 plus 1 is going to equal 1. So the question is this true? So it's not true. So that means that what's in the for loop doesn't execute this time. And then we're going to move on to this next for loop. So let me go ahead and delete a lot besides this space down here. Okay, cool. All right, now we're right here at this next for loop. So k equals 0, okay? K is less than I plus 1, k plus plus. Okay, cool. So let's run through this loop. So we're going to see if 0, which is k, is less than I plus 1. So I is 0, still from earlier, plus 1. Is 0 less than 1? Yes, it is. So it's going to print a hash. Cool. All right. We're going to see if we go through this for loop again, k is going to equal 1, but this side isn't going to change. And the question is going to be, is 1 less than 1? It's not. So this for loop doesn't execute again. And then now we're not going to be at this loop anymore. We're going to go to the next one. So basically that's going to repeat. But let's keep going actually. Yeah. N still equals 2. I still equals 0. Okay. Now we're at here. So this next step says print 2 spaces. Okay, cool. So no matter what's going on with all the other for loops, this is just going to have us print 2 spaces no matter what. So we're going to again represent them with underscores. And let's keep going. So let's go down to this for loop. L is initialized to 0. And we're going to see if L, which is 0, is actually less than I plus 1, which is 0 plus 1. 0 is less than 1. So it is what's going to do in the for loop, print a hash. And then if we go through this loop again, since it was successful last time, we're going to get to 1. Is it less than 1? And nope. So this for loop stops. And then we're going to go down here. So it's going to print a new line. So you won't, or I mean the new line isn't going to be visible. It's just going to go to the next row. So I'll go ahead and delete this. And then keep in mind we're at this next row here. So let's run through it now, because since we were right here, we are done with the first iteration of this for loop where we were in the whole time. And then since it was a successful iteration, I iterates to 1. So now I equals 1. And then let's just run through it. And if you get it, you can skip from here and keep going. But it might be helpful if anyone is curious about how this actually works, just to go through the rest of it. So yeah, let's do it. So J is not, so J updated in the last iteration of the loop where I equals 0, but since we're starting over, J is set to 0 again. So we're going to test it again. So 0 less than n, which is still 2, minus I, which is now 1, not 0, plus 1. So the question is 0 less than 2 minus 1 plus 1? Is 0 less than 0? No. So no spaces are printed. And then we can go to k. K equals 0. And then let's erase this. So does 0, is it less than I, which is 1, plus 1? So 0 less than 2? Yes, it is. So it's going to print 1 hash. And then when we go through it, the k loop again, we'll see that 1 is less than 2 as well. Yes, these are both true. So it's going to print another hash. But then when it updates again, the question is going to be, is 2 less than 2? No. So it stops printing hashes. And then we move on to print 2 spaces. Cool. And then we're here at this for loop. So L, let me erase this. Okay, cool. L equals 0. So now we're going to do the test. Is 0 less than I, which is 1, plus 1? 0 less than 2? Yep, it is. So it's going to print a hash. And then when we go through the loop again, it's going to be, is 1 less than 2? Yes, another hash. And then when we go through the loop again for L, the question is going to be, is 2 less than 2? No. So no more hashes are printed. And then finally, it's going to print a new line, which as we noted is not visible. And then we're going to get up to this first initial loop one more time. And then the question is going to be, since I is now iterated to 2, let me erase these. Let's see if this conditional still holds. So remember that the conditional is I less than n. So since I is 2 and n is 2, the question is 2 less than 2? No. So this whole for loop doesn't get repeated again. And then we can kind of go to like the very end of here, or I mean, let me undo that specific one. Oh, I didn't mean to do that. Yeah, so we can go now down to right here. So this is the end of the for loop. And we notice, oh, that's actually not only the end of the for loop, but it's also the end of the main function, which starts with this nifty yellow bracket. So that's the end of our program. And what's cool is that's correct because this was actually the pyramid structure we wanted to see when n equals 2. So I'll go ahead and run through a few examples of the code actually running, just so we can see that it does work not only for 2, but for all cases. So let's go to make Mario. Then let's implement Mario. So let's do some weird numbers. Okay, cool, it's not accepting them. So it should accept 6. Great. And that's exactly what we want. The pyramid's working great. And we're ready to go. I'll go ahead and do check 50 to see if there's any issues. But we're gonna find that, no, this code works well. I'll get a drink of water real quick. Okay, awesome. All right, so that worked, and we're gonna move on to credit. Awesome, so moving on to credit. Credit's definitely an interesting one. There's some cool things that are going on here. Let's go ahead and go through some of the specifications. So, for getting started, we wanna open VS Code, so yeah, we got that. And then we want to get the credit from the zip file here, awesome. And then assuming all that works well, the goal of this program is to test whether a user's input equates to a valid credit card number. So some background on that is provided here. What's cool is there are some set standards that a lot of the big credit card companies use. And there are ones beyond these ones, but these are some of the ones that we'll focus on in this assignment. So American Express uses 15-digit numbers, MasterCard uses 16-digit numbers, and Visa uses either 13 or 16-digit numbers. And so that means that there's a lot of unique cards that can be generated. For example, the fact that Amex uses 15-digit numbers means that they can have as many as 10 to the 15th, or let me see, million, billion, trillion, quadrillion, or 1 quadrillion unique cards, which is a ton. Interestingly, all Amex numbers start with 34 or 37. Most MasterCard numbers start with 51 to 55. And then there are some others, but like it says here, we're not going to worry about those. And then there are some other things to note. Importantly, we're going to use the Loons algorithm to figure out the validity of a credit card. And the way this works is there's a few steps. So step 1, multiply every other digit by 2, starting with the number second to last digit, and then add those product digits together. So it's definitely a little interesting. We'll check it out how it's implemented. Step 2, add the sum to the sum of the digits that weren't multiplied by 2. And then 3, if the total's digit is 0, or rather no, if the total's last digit is 0, or put more formally, if the total modulo 10 is congruent to 0, the number is valid. So it might seem like, why is it giving us this formal definition if the total modulo what? But that's actually going to be helpful for us. And we'll see why in a second. So let's see this example provided by Professor Malin on this example credit card number. So for the sake of discussion, we're going to take every other digit, starting with this number's second to last digit. So these are all underlined. And then we're going to multiply each of those underlined digits by 2. So see, we have the 1 over here times 2, and then the 0 times 2, etc. That's going to give us 2 plus 0, blah, blah, blah. And then we're going to add those products digits, so not the products themselves together. So the really notable one is this 12. It's broken up into 1 plus 2. So it's not going to be 12 plus 0 plus 8. It's going to be 1 plus 2 plus 0 plus 8. And then 13. So now that sum, 13, is going to be added to the digits that weren't multiplied by 2. So up here, it's going to be the ones that weren't underlined, like 4, 0, 0, etc. So it's going to be added here, and then the result is 20. And then the last digit in that sum, the question is the last digit 0, or is the modulo 10 congruent to 0? Yes, so David's card is legit. Excellent. Let's go ahead and go down here. So here are some implementation details. In the credit.c, in the credit directory, we want to write a program that tests whether the user's inputted number is a valid Amex, MasterCard, or Visa card number per the definitions of each format. Yep. So some examples. The program should behave to where we ask the user to input a number, and then we'll generate an output that either says Visa, Amex, MasterCard, or invalid. And it's up to us to catch non-credit card numbers and non-numbers as well. Okay, so let's go ahead and see how I did it, and I'll explain what's going on. Let's check it out. Okay, so one thing I'll preface with this one is that I actually think there are a few things I've done that are pretty not efficient. They aren't very elegant. They're really, in some ways, brute force. But I actually don't mind that for this problem because I think it was nice for me to visualize exactly what's supposed to happen. So for example, we'll see that I didn't use a ton of loops at all, if any, where I probably could have. Instead, I just did a line per assignment or per mathematical operation. But I'm actually okay with that because it allowed me to see exactly what's happening at each step. And I think it'll make sense what I mean as I go through it. So yes, we're going to start with the libraries here as usual. And then the main function here. Very first thing I did, this might be default with the credit file, I'm not sure, is set long x. So we might remember that there's a few different variable types for numbers. We have int, we have long, we have a few others. Long is great because it allows for that variable to store larger values than an int would. And that's because of the memory limitations that are inherent in int versus something like long. So we're going to prompt the user to type a potential credit card number. So x is the long variable from up here. So we're gonna use the get long function. I'm gonna scoot up real quick. We're gonna use the get long function, and it's gonna ask the user, hey, type a number sequence to test whether it's a valid credit card number. Okay, cool. So that's gonna happen so long as x is negative. So if it's not positive, then it's going to continue asking the user like, hey, like, do this please. So this is actually going to repeat so long as x is negative, meaning that it's not anything that would resemble a valid credit card number. Okay, now let's go ahead and move along. So what's happening right here is this is beginning the Loon algorithm. So it's doing the count sum where it's multiplying every other digit by 2. So this basically is splitting up x into different digits. So for example, this one is going to take the second to last digit and multiply it by 2. And the way I know that's happening is that it's going to take x and then divide it by 10. So like, let's say x is 430, okay? If x is 430, then x divided by 10 is going to be 43. And keep in mind that the divisor here, or the division operator, is based on integers, not doubles, or rather not based on floating point numbers. So if there isn't a whole number integer value that results from the division, it's going to drop whatever is in the decimal places. But with tens, yeah, it's like, for example, if we did 25 divided by 10, it wouldn't equal 2.5 here. It would actually equal 2, because it would basically drop the 0.5 and not round up. So that's something to keep in mind here. But all that said, yes, so 430 divided by 10. In this case, it is an integer result, and that's 43. And then what we're going to do, then we're going to do the modulo of that of 10. So this is the same as writing 43 mod 10. So what does that mean? Mod basically asks us to find the remainder after we do 43 divided by 10. So this isn't like C division, this is like straight up, if we were going to divide it, it would be 4 and remainder 3. So this is what's going to happen. This is what's going to go in the mod result. So 43 mod 10 equals 3. These are both the same and they're both 3. And what's cool is if we go back to our original input, the last integer is 0, but the second to last is 3. And that's exactly what we want for the Loon algorithm. So this is going to equal 3. And then that's going to repeat for every other integer. So let me go and just clear everything. Like I said, we got that equals 3. That's going to repeat for every other integer, starting from the second to last number. And the way we know that's true is that this 10 is multiplied by 100 each time, so that it's going to go from the second to last integer to the next integer, or it's going to go from the second to last integer to not the next integer, but the next integer over. So like 1, 2 steps over, etc., if applicable. And if there's not one, so in this case, it's just nothing. So nothing, or we could say 0 divided by 10, or divided by 1000 rather, is going to be 0. Modulus 0 times 2 is still 0. So these are all going to be 0 in this case. But let's say we had a different case. Let's say we were doing 50430. Then this one would still, or let's say we were doing a different case, 51430. Then 1 is going to get plugged into here, and then it's going to go through that. And like I mentioned, I think there are some things that I could clean up here to make it more elegant, but I do kind of like that each line is a separate step, so I know exactly what's supposed to happen. Okay, moving on. So we want to continue by adding the product's digits to each other. And here, each division operator isolates the 10 digit if applicable, and each modulo operator isolates the ones digit if applicable. So what does that mean? Basically, this whole operation is going to take each digit and it's going to add the product's digits to each other. So keep in mind, these are the products from the Loon algorithm, and then this is going to be the sum of the digits of those products. Sum of digits of products. Cool. Yep. Okay. So how do we do that? Well, each little setup here is going to take one of these digits from up here and then split up that product into its 2 digits. And if you're wondering like, well, how do you know it's only going to be 2 digits? Well, that's basically because since these are multiplied by 2, even if the result of this is a 9, which is the maximum result of any of these is going to be 9. So at most, each of these A through H digits or products is going to be 18. So I know that it can't be more than 2 digits long. It has to be 18 or less. And let's say A is 18 as an example. Let's say A equals 18. So what's happening here is A divided by 10 plus A mod 10. So 18 divided by 10 is going to be 1, because again, it's not going to be 1.8. It's going to omit the decimal place and just keep the integer value. And then 18 mod 10, which is the same as this percent sign in C. 18 mod 10, that's going to be 8. So we notice that 18 got split up into its 2 individual digits, and that's exactly what we want. And that's going to repeat for each of the digits up here, A through H. And that's going to add all the digits together, which is exactly what we want. All right, let's continue along. Now we want to isolate the remaining digits in the number sequence. So remember that X was our user input. We kind of forgot about it because we've been playing around with the individual digits in X, but now we want to go back to the digits that haven't been used. And above we saw that, I'll just scroll. Above we saw that we start with the second to last digit by dividing by 10. Here we want to get the last digit by dividing by 1. And then going through the same process as before, except not multiplying by 2. It's just going to be the digit itself. So we're going to take all of those, and then down here what we're going to do is add the remaining digits in the number sequence. Boom. And that's perfect because from up here, it's going to be J through Q here. And actually, this makes me think one thing I could improve about this code is making the variables more clear. Like instead of saying J, I could say long last digit equals, X divided by 1 mod 10. That would have been way better, but I didn't do that. So that's something to keep in mind. It's generally a great practice to make things as clear as possible in your code. Alrighty, let's go ahead and keep going. Perfect, so now we're down here. We're gonna add R to S, combining the sum of the product's digits to the sum of the remaining digits in the number sequence. So if you're like, what is I and R? I don't even know. So again, that goes back to what I just said. It would have been good for me to label these so that they make more sense. But basically, I and R are these results up here. So I is the sum of the products of every other digit starting with the second to last digit, and then J through Q, or R is the sum of J through Q, which are every other digit starting with the final digit. So S equals I plus R, and then that's going to be basically the whole shebang of the Loon algorithm. And then I commented this out, but I kept it here because this helped me to see whether my Loon algorithm actually was correct. So I just wanted to print %L, %LD. So S is just long, and then yeah, it ended up working great. And so I'm happy about that. Perfect. All right, now that the Loon algorithm's done, the next step is to check if the total S has a last digit of 0 by taking the remainder of S divided by 10 and seeing if it equals 0. And so that's done here. So if S %10 equals 0, remember S mod n is what this means. does S mod 10 equal 0? If it does, then we can go to these steps. However, if it doesn't, then print invalid. And then one more thing I'll mention too is like there's also, yeah, no, that's right. So if it doesn't, if S mod 10 doesn't equal 0, then we want it to print invalid, because even before checking anything else about the first digits or anything, we know that if S mod 10 doesn't equal 0, then it's not a valid credit card, no matter what. So we can just say off the bat, it's invalid. Not only is it not going to be Amex or MasterCard specifically, it's just not going to be a valid credit card, at least in our scheme. So that's great. Next, we can check if the credit card is an American Express. And the way we do that is by checking if the first two digits are 34 or 37. And the way this is checking is, it's basically saying like, hey, like, since we know that Amex cards have a specific number of digits, which I think was 15, we can just divide by 10 to the 14th and then see whether that result equals 34 or 37. Because if it's either of those, then it's Amex. It's not going to be anything else. But if neither of those are true, well, let's check if it's going to be a MasterCard. And there's a few setups that will work for MasterCard. It's either going to be the case that the first digit is 51, or the first two digits rather are going to be 51, 52, etc., all the way to 55. If any of those are true, then we know that the card is a MasterCard. Oh. Excellent. Now, if that's not true, then we're going to go to this else if. So if neither of those are true, then if the first digit is 4 and the card has this number of digits or this number, which we can just check the specification. Oh, but I'm pretty sure it says that, yes, all Visa numbers start with 4, and Visa uses 13 or 16 digit numbers. So that's where we got these possibilities here. We're checking if the first digit is 4 in a 13 or 16 digit card. So if either of those are true, it's going to print Visa. But if none of those are true, then it's going to print invalid. So it might be weird, like, oh, why are there two invalids? Well, just to recap, this invalid down here is saying, hey, like, if S mod 10 doesn't equal 0, then it's invalid off the bat. But this invalids because S mod 10 can equal 0 while none of these other conditions are true. So that can be a possibility. And if that's the case, then we want to still print invalid. Okay, nice. So that's it for that one, actually. I'll go ahead and run the code and we'll just double check that everything's working great. CD credit, make credit, initialize credit, type a number sequence. I'll just type that, invalid, cool. Let's go ahead and do check 50 because it's going to run through its own examples and then let us know what's up. Okay, awesome. Waiting for results. Perfect. Okay, cool. So we can see it ran through a few tests. Does it exist? Does it compile? Do these cards are they correctly identified by the algorithm? And yes, they're all correctly identified. So we're ready to submit, ready to go, and we can head over to the specification just one more time just to see, yep, things are looking good there. And then we can go back to week 1 and double check, okay, did we do everything? Well, we did lab 1, That was the, what was, yeah, it was the, oh, right, population, cool. And then we also did all the problem sets. Hello, Mario Moore, credit. Boom, so we're all good. Excellent work. I hope that was helpful and hope you were able to learn something. Feel free to let me know if you have any feedback or comments. Feel free to subscribe if you want, no worries. And thanks for watching. All right.